And then you can see here we have the middle model that we are using, that we use to push the shapes to, and then you take the shapes from this one to the real model, right?
Yeah.
And then, yeah, now we are going to see the wing walls because that's the part that we have here, and the rest is not um, being used right now. So, okay, great. So then we can run this process, and then sometime soon we'll see that we have a link to Tekla. Um, that will take like 30 seconds or something. Then we'll see that. Okay, something went wrong.
Okay.
See,
Some
okay,
syntax error.
okay, that's probably because this is being modified right now. So let's see. Hopefully this does the trick. So when we run this, we'll see two things. We'll see the wing walls in Tekla, and then we'll get a DGN file, which we can view in MicroStation.
Okay. Okay.
So, so that's basically the way we can check it without using Tekla.
Okay. Okay.
But there's no way to do the parts by visual parameters.
Okay. Inib does.
Yeah, so there's just one way to to define geometry, and that is through text code.
Okay.
Um, but then when you have finished the lines, uh, there's a way to see whether the structure looks like you wanted it to look.
Okay, but I think can you but at least that may be possible that to see the line structure, like not the geometrical shape, but when you're like modeling something in a software in a design software, you must have
Yeah.
seen the lines and like the columns and the kind of thing, right? Or
Yes.
is
Yes.
it like
Uh,
100% visual like written text code?
the part we do is 100% text, and
Okay,
then we can see the resulting structure later on. But when you do the model, that's 100% text based.
okay, okay.
But now you can see the script has finished, and let's go down a bit. So first we'll get some warnings which don't really matter, but then you can see we have linked the Tekla model,
Okay.
and then we get some boxes which
Okay.
which gets placed within the model.
Okay.
And how this thing works is probably too technical for me to answer. but
Yeah.
but we have chosen here what we wanted to show. We have
Yeah.
defined some objects which
Okay.
for this case uh, will be for the wing walls boxes, which means that when we see here, we have now gotten the wing walls in the model.
Okay.
And then you can see we have many boxes with this sequence number, and we can shift this sequence number to make sure that when we do a new push, like we did together,
Yeah.
then we
Yeah.
can shift the sequence number to make sure that we don't get duplicate shape numbers.
Okay. So this is all completely on your hand that whether which sequence you want to use it.
Yeah, so typically we start from one for a new model, but then when we do a new push, we make some dummy boxes like you can see here.
Yeah, yeah,
So
yeah.
for 1 to 9,500,
Mm-hmm.
we make a box that so we make a box that we don't show when we do the Tekla model. But that just means that the numbering that we have from IPTAS gets higher because we have some boxes, and these boxes get numbered, but they don't show up in Tekla because we have chosen not to show them.
Okay, okay.
So yeah, so that's how we shift the shape numbers to
Yeah,
make sure that we don't get duplicates.
yeah, yeah.
And then yeah, then let me show you the MicroStation file.
Okay.
Uh, so typically when we do modeling, we just use a MicroStation file,
Mm-hmm.
and let's see here how it looks. So that's MicroStation, and in that we can see the wing walls that we had in Tekla.
Yes. Yeah.
So
Okay.
so basically we are just making a 3D representation showing the model, but
Mm-hmm.
uh, then somehow we we can use that 3D geometry and show it within Tekla.
Okay.
So that's basically what we are doing. And when we are doing like a model, then we'll um, use that to verify what we are doing is what we want it to be. Because let me see. Um, so for a bridge, this is a file that defines the superstructure, meaning the U-beams and the deck slab and so on, the parapets, and that is just text. There's text, and yeah, that's it basically. But then when we have finished some text, we can go in and we can make a visual representation showing the model. We can show the boxes, and then we can see that the bridge looks like we wanted the bridge to look.
Okay. Okay. Yeah, this is
So
the.
yeah, so we are basically just using some link to show what we show here in Tekla, basically.
Mm-hmm. Okay. Yeah, yeah, yeah. Yeah, as long as I can understand, like maybe there could be two way, like whether we are creating the DGN file and after that maybe that script is like exporting this DGN file to the Tekla where we are making the items with a concrete element and providing the sequence for the shapes. And in a code also I can see that you are making shapes, and that then these shapes are converted into the multiple shapes in Tekla and joined together with the sequence. And this is really nice to see like the model you exported is like fairly accurate, and this is like really innovative thing to do that.
Yeah, so basically we can do very precise models, um, because yeah, we are free to define surfaces that are curving and so on.
Yeah, yeah.
And for this particular bridge, we had a problem due to the skew. So we modified the wing wall
Mm-hmm.
uh, standard model to have a feature where you could specify this distance here
Mm-hmm.
being straight, and then this distance here being straight. Because
Okay,
previously we had just uh, the first version was probably to have just one straight line from this corner to this corner.
okay, okay.
And
Yeah.
and then later on we modified the standard model to be straight from here to here, then
Mm-hmm.
from here to here, and then yeah, so on, right? And and then later on, yeah, we chose to also make this one here follow
Okay.
this line. So now we have that choice.
Okay,
Uh,
so that is that also handle the curves or like any curve structure in your code? Like, is it also possible to make it a curvature profile or something, or like is it only bounded for the straight?
Well, we have done curved um, boxes when we do the deck, for instance.
Uh-huh. Yes, yeah, yeah, yes.
Yeah, so that is definitely possible.
Okay, okay. Single or
But
double curve both?
uh, that's a good question. We have just done single curved
Yeah.
so far, right? But
Yes.
double curved is probably possible. But there's just one drawback by doing this, and that is when we do these kind of things, we don't use like your standard profile from Tekla, right?
Yes.
Meaning that you have a a difficult time modifying
Mm-hmm.
a wing wall like this, right? By
Yeah.
hand through
Yes.
Tekla.
Yes.
So that's like the drawback that you have by getting the geometry from IPDAS, right?
Yeah.
Because
Yes. Yeah.
now in this model we don't have it, but let's say for the piles, those follow a like a standard Tekla profile, right? Uh, some
Yes.
kind of circular,
Yes. Yeah.
yeah, cylinder. And in that case, you can modify the length with no problem, right?
Yeah. Yeah. Right.
Yeah, so for some cases, we have used like standard profiles, but that is very difficult to do sometimes for us because, yeah, when you have
Yeah.
a wing wall like this with this kind of shape,
Mm-hmm.
then we define the shape by just defining boxes,
Yes. Yeah, I
and we
can
can
understand that. Yes.
and we can represent those boxes without problems in Tekla. But
Mm-hmm.
then by doing that, we are doing this these dead kind of profiles that
Right.
are that cannot be modified from your end.
Yeah, right, right, right. I can understand that, yes. Making a Tekla element within a different software, you have to use the multiple setups and the settings. So, or the precision, whatever it requires. So, yeah,
Yeah,
instead of making that fixed profile is like, but again, then like if you use the Tekla native element in a IPDAS code, then there might be a possibility of like not getting a DGN correct, because I don't think that DGN will work on the same way how Tekla works. So fixed profile is, I think, is the only way we can do it, like with a different element as well. Yeah,
yeah,
this is nice. This is nice. Thank you for the insight on the codes. Yeah,
yeah. You are welcome. Yeah,
yeah,
that's.
yeah,
But
yeah.
yeah, we are typically trying to use the standard Tekla profiles when it's possible. But yeah, sometimes there's no way to do it like when we have wing walls, parapets, stuff like that.
Okay. By any chance, you know, like who like initially made this script for exporting this thing, like Tekla or IPDAS integration?
Like the really uh, like the technical part
Yeah, the technical
behind the
part who,
script.
yeah, behind the script,
Yeah,
yes.
yeah. It's probably Last Stick and Geo.
Lars Dig.
Yeah.
Okay. 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 What is his initials?
Let
Do
me check that and then get back to you.
Okay. Okay. Sure. That
Yeah.
would be fine. Yeah. Thank you, Sebastian, for that, for
You
information.
are welcome.
Yeah. Okay. Okay then.